This video is for Nova Online Math 161 and we are reviewing for the final exam. And the topic that I have here is graphing rational functions. Oh, quadratic over linear. This is one of the more difficult ones, but we're going to go over this together. Okay, so quadratic over linear. Look at the difference in degrees. The exponents or the degrees of the numerator and the denominator. The biggest exponent on top of the fraction is 2. And the biggest exponent in the bottom of the fraction is 1. Now remember, this is the case where slant asymptote happens. When the degree of the numerator is greater than the degree of the denominator by exactly 1, slant asymptote will happen. So, well, let's go find all the asymptotes first, because the direction says graph the function, label all asymptotes and intercepts. So let's go find, let's see if there's any vertical asymptotes first, okay? If you want to find vertical asymptotes, I know we can always just look at the denominator, but we have to be careful. Sometimes if they simplify, then it may leave a hole in the graph instead of a whole vertical asymptote. I'm going to try to see if I can factor the numerator to see if x minus 3 will cancel, okay? So, two numbers that multiplies to be 4, but I want them to add up to -3. Let's think. I'm thinking 4 times 1. Okay. 4 times 1 is 4. And if I make 4 a negative and 1 a positive, they will totally multiply to be -4, and they will add up to -3. So I was able to factor it. But you know what? I'm sorry. That didn't lead us anywhere because look, is anything going to cancel? Not really. But listen, if they were to cancel, let's say that I ended up with -x minus 3. And if they cancel, then it doesn't have a vertical asymptote. Then it's going to have a hole at that cancel that value, okay? Now, this, we didn't really cancel anything out. So let's go ahead and find the vertical asymptote here, okay? Vertical asymptote happens at the 0 of the denominator, okay, after you cancel everything out. And the denominator is x minus 3. So what you want to do is set up x minus 3 equals 0. And when you solve that for x, we get x equals 3 as the vertical asymptote, okay? Now, well, we have to still, all right, let's talk about the horizontal asymptote. Horizontal asymptote. In pre-calculus, what we learned to find the horizontal asymptote by looking at cases, okay? When degree of numerator is greater than the degree of denominator, there's no horizontal asymptote, okay? So, and you know, there are two other cases, but for this particular function, when 2, the exponent, look at the highlighted numbers here, when 2, well, the degree of the numerator is bigger than the degree of the denominator, we do not have any horizontal asymptote, okay? But because it is greater than the denominator by exactly 1, this is the case we have a slant asymptote. So slant asymptote is one of the more challenging asymptote to find. So I'm going to show you how to find the slant asymptote here. It doesn't have horizontal asymptote, but it will have a slant asymptote. So to find that, you need to perform a division, okay? So go down. I'm going to say, here's my attempt to find the slant asymptote. Some books call it oblique asymptote, but I think our textbook calls it slant asymptote. Divide. If you like polynomial long division, do that. I like synthetic, so I'm going to go with synthetic division. So divide the numerator by the denominator, okay? So I'm going to do a synthetic division, put that little 3 in the box. I'm going to put the coefficients of 1, -3, and -4, and perform the division. Bring down the 1 exactly the same. But now multiply that 1 by 3 and add that 3 with negative 3. Do 3 times 0 and get 0. Add to get the remainder of negative 4. So when you are finding the slant asymptote, ignore the remainder, okay? Remainder not going to do anything. But we are going to use the quotient to write the equation of the slant asymptote. So here's the slant asymptote equation, okay? It's going to be y equals 1x plus 0, okay? Using the quotient from the division, we can tell that the slant asymptote equation is simply y equals x. Okay, so we know enough, well, asymptote-wise, we know enough, but we do need to plot some intercepts, they say. So this one's a little longer problem. I think I'm going to add another page now to find some intercepts, okay? So let's find the easy one first, the y-intercept. If you ever want to find y-intercept, you just plug in x equals 0. Set x equals 0. So we will get y equals, on the numerator, we'll get 0 squared minus 3 times 0 minus 4. In the denominator, we'll get 0 minus 3. So that simplifies to negative 4 over negative 3. So positive 4/3 is where the y-intercept will be. Now to find the x-intercept, we set the whole function equal to 0. We set the y value equal to 0. So do this. Say 0 equals the entire quotient. Now, the quotient is equal to 0, or the fraction is equal to 0 when the numerator is equal to 0, right? So we can just set the numerator equal to 0. If not, we can talk about, we can multiply both sides by x minus 3 to cancel out that x minus 3. But what happens when you do x minus 3 times 0? Well, you just get 0, right? So you really just end up getting whatever is on top of the fraction equals 0 as an equation to solve, okay? Quadratic. All right, let's focus on this part now. Let's see if we can use factoring to solve this, okay? Two numbers that multiplies to be 4 are 4 times 1. And if I make the 4 a negative and 1 a positive, they will add up to negative 3. So what are the two x-intercepts? X equals positive 4 and x equals negative 1. So this rational function has two x-intercepts at 4, negative 1. Now, guys, we have so many clues here to use to graph this, okay? So I'm going to go ahead and draw a big xy axis, okay? Xy axis. But I'm going to have to go back up to find some of the clues we had, okay? Now, what was the first asymptote we found? Let me go back up. The vertical asymptote is at x equals 3. So let's go sketch a dotted line at x equals 3 first, okay? So go 3 to the right, 1, 2, 3. I'm going to get a red dotted line tool and then sketch a dotted line going through x equals negative 3, okay? It's not super straight, but you know what I mean. Okay, so we got that. So that's the vertical asymptote of x equals 3. Now this function didn't have any horizontal asymptote, but I remember that we had a slant asymptote at where? Slant asymptote of y equals x, y equals x. So let's graph y equals x. That's an identity function, right? So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. And when x is 3, y is 3. That's enough dots for me to graph a straight line function. So I'm going to go ahead and get a dotted line tool and connect these 4 dots in a row to have a perfectly diagonal slant asymptote. So we got the asymptotes placed in. The blue one is a slant asymptote. The red dotted line is the vertical asymptote. So asymptotes placed. What were the other values that we can plot? Let's see. The y-intercept was at 4/3. So what is 4/3 in approximate decimal? Because I actually want to plot it instead of just having a fraction. So hold on. 4 divided by 3, that's approximately 1.3. So I'm going to go and plot 1.3 on the x-axis, okay? I'm sorry, on the y-axis. So there is my y-intercept of 4/3. I made the dot really fat so that it looks like 1/3, okay? I'm sorry, 4/3. Now, we did have two other values to plot on the x-axis, the x-coordinate of 4. So go 4 to the right and plot a point. And go, well, now this one's not interesting. Go 1 to the left and plot a point. And now that should be enough for us to graph a function. I'm going to use my creativity over here to show you what the function looks like. But, you know, the more points you plot, the more accurate it will be. But I can go ahead and sketch something at this point. Watch this for me. To the left end, I'm going to connect these two dots. The graph will get infinitely close, probably not that rapid. It will get really close to that slant asymptote, but it will never cross it. It will just get really close to it, okay? Now, it will go up, but it will be bounded by that red vertical asymptote, okay? It will be bounded by that red vertical asymptote, okay? It will never be able to cross it. So the left side, the graph will look like that. And the right side, something similar will happen. I'm going to have to make the graph to go up, get really close to that slant asymptote. But as I drop the tail down, I will be bounded by that vertical asymptote. I will not be able to cross it. It's not the I don't think I graphed the most pretty graph right here, but I'm going to show you what it should look like, okay? But look, this graph has all the important points, all the vertical and slant asymptotes. So if you can do that on the exam, that will be a full credit, right? But let's see. It's a little prettier than that. So I'm going to go ahead and, because I have my graphing calculator open, I'll show you what it should look like, okay? So f of x equals x squared minus 3x minus 4 over x minus 3. Now that's the graph, but I'm also going to place in our vertical asymptote of x equals 3. And I'm also going to place our slant asymptote of y equals x using dotted line tool, okay? And I'm going to show you, okay, that we got the right graph. Look at that, okay? Right? So very wide, right? Does it have an x-intercept at 4 and -1? Let's see. I click this dot. Yes, it does have an x-intercept at 4, 0. And it does have another x-intercept at -1, 0. And I'm about to click on that y-intercept, which is one at 0, 1.333. So that is 4/3. So we did it right. It was just a little bit difficult for me to graph the I'm sorry, it's ugly. But because, you know, it was just a regular graph paper. It was a blank piece of paper, but we do have everything graphed right. Got the vertical asymptote, we got the slant asymptote, and all the intercepts that we needed. And it does look like it, right? Okay, but for this quadratic over linear case, okay, I want you to remember that to find the slant asymptote, do the division. I showed you how to do the synthetic here, but just grab the quotient to write the equation for the slant asymptote. This particular graphing rational is one of the harder ones, but this is what you want to prepare for your final exam, as you will have a quadratic over linear case.